4 astronauts, 1 rocket, 4 days until launch. History is about to be made.
And if you think that's the only jaw-dropping story in space today, wait until you hear about a comet that literally stopped spinning and started going the other way.
I'm Anna.
I'm Avery.
And this is Astronomy Daily, your daily guide to everything happening in space and beyond. Welcome to Season 5, Episode 75.
Let's get started then.
All right, let's start with what is, without a doubt, the biggest human spaceflight story in more than 50 years. The crew of NASA's Artemis II mission has arrived at Kennedy Space Center in Florida, and the countdown is well and truly on.
That's right. Yesterday, Friday the 27th, NASA astronauts Reid Wiseman, Victor Glover, and Christina Koch, along with Canadian Space Agency astronaut Jeremy Hansen, touched down at Kennedy's shuttle landing facility in their T-38 jets, arriving from Johnson Space Center in Houston. They were greeted by NASA Administrator Reid Wiseman and a crowd of reporters that was, by all accounts, the largest anyone had seen for an astronaut arrival in a very long time.
And the energy was electric, Avery. Commander Reid Wiseman stepped out onto the runway, pumped his fists, and said, and I'm quoting here, "Hey, let's go to the moon." That says it all, really.
It really does. So the plan. Launch is scheduled for no earlier than 6:24 in the evening Eastern Time on Wednesday, April the 1st. I know, April Fool's Day, but this is no joke. The window stays open until April 6th, giving the team a 6-day buffer, but mission managers are pushing hard for that first opportunity.
And the mission itself? Artemis II will send all 4 crew members on a 10-day journey around the moon and back to Earth aboard NASA's Orion spacecraft, launched on top of the Space Launch System, the most powerful operational rocket in the world. They won't land on the moon, that's Artemis III's job, but they will fly farther from Earth than any human has ever been. The Apollo 13 record, set back in 1970, will be broken.
The crew are now in quarantine at Kennedy, spending their final days reviewing mission procedures, completing medical checkups, and spending precious time with family. The countdown clock is set to begin ticking at 4:44 p.m. on Monday, and from that point, it's all systems go. For anyone who watched the Apollo missions as a child, or who has simply dreamed of humanity returning to the moon, this is the week we've been waiting for.
We will absolutely be following this one closely over the coming days on Astronomy Daily. And for our listeners down under in Australia and across New Zealand, April the 2nd is your morning to set those alarms.
Now, from the moon to a tiny snowball tumbling through our inner solar system. And when I say tiny, I mean it. Comet 41P, formerly known as Tuttle-Giacobini-Kresák, measures just 1 kilometer across, about 3 times the height of the Eiffel Tower.
And yet, this little cosmic wanderer has just done something that scientists have never, in all of recorded astronomical history, observed before. It reversed its spin.
That's right. A new study published this week in the Astronomical Journal, based on observations from NASA's Hubble Space Telescope, reveals that Comet 41P first dramatically slowed its spin, nearly came to a complete stop, and then started going the other way. Researchers describe it as a kind of merry-go-round effect. The comet's own outgassing jets, streams of gas blasted off its surface as it heats up near the sun, were pushing against its spin so hard that they eventually flipped it.
To give you a timeline, back in March 2017, the comet was spinning at a regular pace. By May 2017, Swift Observatory data showed it had slowed to 3 times that rate. And then when Hubble took a look in December 2017, the comet was spinning fast again, but in the opposite direction. The whole reversal had happened within months.
Now, here's the twist, and it's a sobering one. Study author David Jewett of UCLA says that because the comet is now spinning so rapidly in its new direction, centrifugal forces could overcome the comet's own weak gravity. And his conclusion? Quote, "I expect this nucleus will very quickly self-destruct. We may be witnessing the final chapter of Comet 41P's long life."
Which makes these observations all the more remarkable. The comet is thought to have been in its current orbit for around 1,500 years. And in one close pass of the sun, we got to watch it undergo a transformation that would normally take centuries in just a matter of months. Hubble really never stops delivering the goods.
Story 3 takes us to one of the deepest mysteries in modern cosmology, and potentially one of the most significant detections in the history of gravitational wave astronomy.
Back in November last year, LIGO, the Laser Interferometer Gravitational Wave Observatory, picked up a signal that stopped researchers cold. The gravitational wave appeared to come from a merger event involving at least one object that weighed less than a single solar mass. And here's why that matters. Through all known processes of stellar evolution, that simply shouldn't be possible. Regular black holes form from dying stars, and the minimum mass for that is a few times our sun. So what was it?
Well, this week, astrophysicists Nico Cappelluti and Alberto Magaraglia from the University of Miami published the compelling answer in the Astrophysical Journal. Their conclusion: it may be a primordial black hole, an object formed not from a collapsing star, but from the unimaginable density of the universe itself in the first fraction of a second after the Big Bang.
Primordial black holes are one of the most tantalizing concepts in theoretical physics. They could range from microscopic to enormous, and crucially, they are one of the most compelling candidates for dark matter, the invisible substance that makes up roughly 85% of all matter in the universe. We can see dark matter's gravitational effects everywhere we look, but we have never directly detected it. A confirmed primordial black hole detection would transform our understanding of the cosmos overnight.
The Miami team modeled how many primordial black holes should exist, how often they should merge, and how frequently LIGO should detect them. And remarkably, the numbers lined up. One rare detection event exactly as their theory predicts. It's not confirmation, one signal is suggestive, not conclusive, but it is a genuinely thrilling lead to follow. As Cappelluti himself put it, the most plausible explanation for the LIGO signal, which lacks any conventional astrophysical explanation, is the detection of a primordial black hole.
Next-generation detectors, including the space-based LISA mission planned for the 2030s and the ground-based Cosmic Explorer, 10 times more sensitive than LIGO, will hopefully shed more light on this. For now, we may have just received our first signal from the dawn of time itself.
Here's a story that bridges ancient human history and cutting-edge astronomy. In the year 185 AD, Chinese astronomers recorded a strange new star appearing in the sky, one that would remain visible for up to 8 months. They called it a guest star. What they had actually witnessed was one of the earliest supernova explosions ever recorded by humanity.
Fast forward 1,800 years, and that same ancient explosion, now known as supernova remnant RCW86 or SN185, has just been given its most detailed examination yet. NASA's IXPE mission, the Imaging X-ray Polarimetry Explorer, has delivered a breathtaking new image of the remnant's outer edge, combining its unique X-ray polarimetry data with observations from NASA's Chandra Observatory and the European Space Agency's XMM-Newton telescope.
So what did they find? IXPE targeted the outer rim of the remnant, highlighted in a vivid purple ring in the new image, and discovered something fascinating. The expanding shell of superheated gas, which had been blasting outward at tremendous speed for 2,000 years, appears to have stopped at the edge of a large, low-density cavity that surrounded the original star. In other words, the explosion ran into a wall, and the new data helps explain why the remnant expanded so much faster than astronomers initially expected.
IXPE achieves this by studying the polarization of X-rays, essentially how those high-energy light waves are oriented as they travel through space. It's a technique that opens a completely new window on the behavior of exploding stars, black holes, and pulsars. The resulting composite image, with yellow for low-energy X-rays, blue for high-energy, and the purple IXPE data overlaid, is genuinely one of the most beautiful things you'll see in space science this week. We'll have a link in the show notes.
There's something deeply moving about this story. A star that humans watched die with the naked eye 2 millennia ago, recorded by diligent observers in ancient China, is still revealing its secrets today. Science is a very long conversation.
Story 5 brings us a story that's both deeply human and profoundly relevant to the future of space exploration, and it connects directly to our lead story today about Artemis II.
Earlier this year, you may recall, NASA made headlines when it announced that the Crew 11 mission aboard the International Space Station was being cut short due to a medical concern. The agency initially declined to name the astronaut involved. But in late February, veteran astronaut Mike Fincke, a 4-time space flyer and retired U.S. Air Force colonel, came forward at his own request to confirm that he was the person affected.
And this week, for the first time, Fincke spoke in detail about what actually happened. In an exclusive interview with the Associated Press conducted from Houston's Johnson Space Center, the account is extraordinary.
Fincke says he was eating dinner on January 7th, the evening before a planned spacewalk, when it suddenly hit. He lost the ability to speak. He felt no pain. The episode lasted around 20 minutes. His crewmates, seeing him in distress, immediately contacted flight surgeons on the ground. It was completely out of the blue, he told the AP. It was just amazingly quick.
NASA used the station's ultrasound machine during the event, which Fincke credits as genuinely useful, and his condition quickly stabilized. But NASA's medical team determined that the safest course of action was an early return to Earth, so that Fincke could access advanced medical imaging not available on the ISS. NASA canceled the following day's spacewalk, and on January 15th, Fincke and his 3 crewmates, Zena Cardman, Kimiya Yui, and Oleg Platonov, splashed down in the Pacific Ocean about a month ahead of schedule.
Here's the part that is both remarkable and sobering. As of this week, doctors still do not know what caused it. A heart attack has been ruled out, but the precise nature of the event, whether neurological, cardiovascular, or something else entirely, remains undiagnosed. NASA is now reviewing astronaut medical records to determine whether anything similar has occurred in space before, potentially without being recognized.
And here's why this matters so much right now with Artemis II 5 days from launch. On the ISS, if something goes wrong medically, astronauts could be home within hours. On a 10-day lunar mission, and certainly on any future mission to Mars, that option doesn't exist. The Fincke incident has become a landmark moment for space medicine, prompting urgent conversations about what medical capabilities need to exist on deep space vehicles. Fincke himself framed it with characteristic composure. Spaceflight is an incredible privilege, and sometimes it reminds us just how human we are.
And Mike Fincke says he feels fine now and is continuing routine post-flight conditioning at Johnson Space Center. We wish him a full and swift recovery, and we salute the crew and the medical teams who got everyone home safely.
And finally, eyes on the sun, because our nearest star has been putting on a show this week.
That's right, a new sunspot region, designated AR4403, rotated into view on the eastern solar limb on March 26th, and it wasted no time making its presence felt. Within hours of coming into view, AR4403 unleashed the powerful M3.9 solar flare at 6:11 UTC, triggering an R1, that's a minor, radio blackout over the Indian Ocean.
Now, the good news, as of today, Saturday the 28th, the sun is relatively quiet. AR4403 has calmed after its initial outburst, and space weather forecasters are expecting mostly quiet conditions through today. But there's a catch, and it's worth noting for our listeners who love aurora watching.
From Sunday the 29th, a co-rotating interaction region, a dense zone of compressed solar wind, along with a high-speed stream from a coronal hole are expected to arrive at Earth. And a faint coronal mass ejection from the recent activity could also graze our planet's magnetic field around that time. Space weather forecasters are predicting unsettled geomagnetic conditions, which could, in favorable circumstances, push auroras to slightly lower latitudes than usual.
So for our listeners in southern Australia, Tasmania, and New Zealand, particularly those of you with dark skies away from city lights, Sunday and Monday nights are worth watching. Check your local aurora alert apps, keep an eye to the south, and fingers crossed for clear skies. And if you capture anything spectacular, we'd love to see it. Tag us at Astro Daily Pod.
We'll be keeping an eye on developments and may have an update in Monday's episode if conditions escalate.
And that is a wrap on an absolutely packed edition of Astronomy Daily. To recap what we covered today, the Artemis II crew has landed at Kennedy Space Center with April 1st launch in their sights. Hubble has documented the first ever spin reversal of a comet, and that comet may be on borrowed time. LIGO may have detected a black hole born at the dawn of the universe itself. NASA's IXPE telescope gave us the finest portrait yet of a supernova first seen by human eyes in 185 AD. Astronaut Mike Fincke spoke for the first time about his still mysterious medical emergency in orbit. And the sun is stirring, with possible aurora opportunities on the way for Southern Hemisphere skywatchers.
What an extraordinary time to be alive and looking up! If you're enjoying Astronomy Daily, please subscribe, leave us a review, and share the show with anyone in your life who loves the cosmos as much as we do. You can find us at astronomydaily.io and across all platforms at Astro Daily Pod.
Until Monday, keep looking up.
Clear skies, everyone.